Thank you, Whitney. Hello, everyone, and welcome to our webcast today on securing access to your host assets. My name is Yvonne Wheaton, and I'll be your moderator today. I represent Software Diversified Services. Here's our agenda for the next 50 minutes or so. First up, we have Stu Henderson from the Henderson Group. Since 1990, he's directed his own firm, the Henderson Group, which provides computer security consulting and training in a variety of technical areas. Mr. Henderson is an experienced consultant who specializes in effective computer security for IBM mainframes, Unix, and Windows. To set the stage, Stu will be presenting the evolution of mainframe networking. Following Stu, we have Patrick Fournier from SysperTec. Patrick has an extensive background in enterprise modernization services. He currently serves as a solution architect for the Virtel Web Suite, which is published by SysperTec. Patrick will be introducing you to SysperTec Virtel Web Access and will be discussing security exposures. His solutions are critical in today's infrastructure using the Virtel Web Access product. Joining us today for Q&A is John Bachiochi from SysperTec. John has been in the mainframe system software industry since 1977. His main focus is extending legacy applications by providing web access modernization and integration solutions that leverage these applications. During our webcast today, you're welcome to send us questions. We'll be holding a Q&A session at the end. If you have any questions during our presentation, just place them in your question box. Okay, so let me have a few minutes of your time and let me tell you a little bit about Software Diversified Services. SDS, or Software Diversified Services, has been providing mainframe solutions to the market for over 35 years. We have over 1,000 licensed customers worldwide, including Global 500 companies. Our headquarters are located in Minneapolis, Minnesota. SDS now supports over 20 ZOS, MVS, VSE, and VM mainframe systems products. Our flagship products are dedicated to network management, security solutions, and performance solutions. Over the years, we've developed more solutions for the distributed environment. We've added to our mainframe portfolio, and we've partnered with key subject matter experts for excellent software solutions. SDS has strived to bring software solutions to the marketplace that will provide both cost savings to you while still using elegant and state-of-the-art functionality. Today, we are pleased to be presenting with our partner SysperTec, with whom we have various product offerings in the Virtel Web Suite. Okay, so let's get started. So without further ado, I'd like to turn this presentation over to Stu Henderson. Stu?
Thanks, Yvonne, and thanks everyone for listening. Have you ever woken up and discovered that something had gotten worse or more complicated so gradually that you didn't realize it was happening until it reached the breaking point, and then you realized, oh my Lord, this has gotten so complicated, I can't stand it, I can't manage it, I didn't realize this was happening, but it's reached a breaking point. Well, that's what I want to talk to you about today, because this has happened for many of us with mainframe networking. So I want to talk about the history, how we evolved, and what happened, how things got more complicated, and why. And then talk about some of the issues, the management tools, and the purposes of these tools, and why they become important. And then lay this out with a call for action. So I'm going to describe the evolution for you and describe some of the issues, and then leave it to other people to talk about the solution. Many decades ago, in fact in the last century, terminals were connected to the mainframe. Almost you could consider it hardwired. That is, a terminal would be connected not just to the mainframe, but to one specific application like CICS on the mainframe. And so if you wanted to use that terminal for TSO, you couldn't. You needed to get another terminal. It was very simple, very easy to secure, and not complicated at all. Now, CICS and TSO and other programs, IMS for example, knew how to talk to these terminals. These were called 3270 terminals. It's an IBM model of terminal. You may have heard it referred to as green screens. But these pieces of software were able to talk to 3270s because they were aware of the language that these terminals spoke. There were special codes that would tell the terminal how to define fields on the screen, and so if you didn't know how to talk 3270, you'd have trouble really communicating with the terminals. But the standard stuff like CICS and TSO knew exactly how to do this. Now the next step, we got some added flexibility, as you're going to see. As flexibility increased, the complications also increased. IBM gave us VTAM. VTAM is software that works on the mainframe, and it controls all the telecom, all the terminals, and even TCP/IP. And now our 3270 terminal, we're still talking 3270, but the terminal is in effect, it might as well be hardwired into VTAM, but VTAM gives you the flexibility to say your terminal can talk to CICS prod or CICS test or TSO. That is, VTAM would let you talk to the different applications without having to get another terminal. This added greatly to flexibility, but again, you'll see this adds to a little bit to complications. Now then we got more flexibility when we added the internet. Now with the internet, we no longer have we no longer have 3270 terminals, we have Windows PCs connected to the internet is connected to the mainframe, and VTAM now has support for TCP/IP. Now we can still be talking to CICS prod or test or TSO or IMS. They all still expect 3270 commands and protocols. So on our Windows computer, we now have an emulator program that tells your Windows computer, pretend that you were a 3270 terminal so that you can talk to CICS and TSO and the standard mainframe programs. All this going through the internet. So these terminal emulators, you might be familiar with Attachmate or Hummingbird, PCOM. There's a large number of them, but what I think you may be starting to realize is all of a sudden there are more places where we can set options. We can set security options, we can set administrative options. We can all of a sudden discover we're paying for additional software and maybe even in some cases additional hardware. But we barely noticed it because we were getting this additional flexibility. Now, we got even more flexibility because we could tell our Windows computer, don't run a terminal emulator program, don't pretend to be a 3270. Instead, run a standard TCP/IP program like FTP, File Transfer Protocol. And now what would happen is your Windows computer, just running Windows, no terminal emulator, would run an FTP program on the Windows computer, which would talk through the internet to VTAM and TCP/IP on the mainframe, and VTAM and TCP/IP would pass the requests to the FTP program running on the mainframe, so you'd have the FTP client program on your PC talking through the internet through VTAM and TCP/IP to the FTP server program running on the mainframe, and this would work fine. So again, we've got more flexibility. With your Windows PC, you could run a terminal emulator program, and with the terminal emulator program, you could then talk to TSO or CICS or whatever. But if you didn't want to talk to them, if you wanted to talk to standard TCP programs like FTP, you could do that just as well. But instead on your PC, instead of running a terminal emulator program, you would run an FTP program, or if you wanted to talk to the HTTP program on the Windows PC, you would run Internet Explorer or whatever browser you have. So your browser like Opera or Internet Explorer or Firefox would know how to talk to HTTP. So again, we have lots of flexibility. On the PC, you can run a terminal emulator program, or you can run FTP or HTTP, or which would be Internet Explorer, or several other programs, and all of these different ways you can connect to the mainframe. Great increase in flexibility. What we didn't notice is we've got more possibilities for software costs, for administrative overhead, for security settings, for encryption settings, and so on. Now, the part of the problem that many people realized we were facing then is we have this large inventory of CICS COBOL transaction programs. These are the programs that have been running for financial and other institutions for since the beginning of the mainframe. Someone did a study recently. They took all of the financial transactions processed by computers in a given 24-hour day and weighted them not by transaction count, but by dollar volume. And they said weighting it by dollar volume, more than 90% of the financial transactions processed by computers were handled by COBOL transaction programs running under CICS on the mainframe. So this is great as long as you're doing 3270, but if you want to talk to CICS, and if your whole company is dependent on these CICS transaction programs, but you want to talk over the internet, all of a sudden things are more complicated. So you're going to need, well, there are a couple of approaches. One of them would be to find some way to simplify things. But the way that we have been given, one of the many ways we've been given, is we have added something called WebSphere Application Server. This comes with the mainframe. It's part of ZOS. And so what we now have is our PC, which could be running something like Internet Explorer, but it talks through the internet to VTAM and TCP/IP, which might hand the request to HTTP. HTTP can hand the request to this other software called WebSphere Application Server. WebSphere Application Server might talk to a Java virtual machine with programs running and written in Java and running in the Java virtual machine, and the Java programs might invoke CICS programs which might talk to MQ or DB2 or whatever. So we've gotten much greater flexibility. Our inventory of CICS transaction programs can now be used through this convoluted process so that we can talk to them from over the internet from PCs without terminal emulator programs. But again, you can see there are a lot of places where things have gotten complicated. It's more difficult to manage. There's additional software to pay for. There's administrative overhead. There's a lot of people you'd want to coordinate. If the Java programmer doesn't know the COBOL programmer, and neither one of them knows the VTAM systems programmer or the people who are administering TCP/IP or so on, you can see it's very difficult to get all of the pieces to fit together efficiently with good security and reliably. So let's talk about the management control points, because a management control point is a place where you implement some automated mechanism so that management can know that things are happening the way they're supposed to be. The management tools that let you know, oh, things are being done right because at this control point I have this control and I know it's effective. The management tools are needed to manage software and hardware costs. For example, if you increase encryption, you could add to your CPU requirements. If this forces you to go to a more powerful CPU, that it can increase your software licensing costs. The whole problem of encryption, there's changing technology, changing regulations, and you need to make sure your encryption is being done right. For good security, you need to know that each user's identity is being reliably proven, and that only authorized users are allowed to use the computer to begin with. And if you want to have good management controls, you want monitoring. You want some way of knowing that what is happening is what you want it to be. It's according to your baseline. And if there's any change or displacement from your baseline, you want to know about it. So you want monitoring to give you confirmation that things are going the way you want them to, but also to tell you anytime it's not. You want to be able to keep up with compliance, changing regulations and technology, and you can imagine now the cost of administration for all these different moving parts with all these different people in all these different locations gets much more complicated. And the overhead of all these different administrative tasks for all the different pieces of software is expensive, and it's also a chance for security to break down, for change control to break down, and so on. So remember what it was like a long time ago? We evolved from here when life was simple. We didn't have a lot of flexibility, but life was simple. And then we got here, and when we got here, we had a whole lot more flexibility, but the control has been dispersed. When we were back in the first image here, we were looking at, if you were doing a security audit, it was very easy. It was one step. Make sure the door to the terminal room is locked. There wasn't a whole lot to look at. But now where we are, if you look at all the different moving pieces, all the different configuration files, all the different options, and all of the different people involved in all the different locations, it's very difficult to keep your arms around this, to have the controls in place to know that everything is working together the way you want it to. So we're going to talk about a couple of different ways that the control has been dispersed, looking first at the PC. Because in the Windows PC, you've got Windows itself, you've got the Emulator program, which can cost money, and both Windows and the Emulator program have administrative configuration options. And if you're running FTP or Internet Explorer or other programs, all of these have administrative options, and these are now being run by people maybe outside of your control. In addition to the disbursement of control over the PC, control has also been dispersed, which makes it harder to manage, over the Internet itself. Because of course we have our customers, maybe we're doing online banking or internet commerce of one kind or another, so they're talking to the Internet, but we also, because of the flexibility of the Internet, have the risk that people in other countries are also trying to connect to our mainframe, and again, we don't have management controls over all the people in all the other countries. And we've also got our own programmers. You might have a contract programmer or an employee who is connected to the internal TCP/IP network, which might as well be an extension of the Internet, and that may or may not give him or her the ability to connect through your internal network to your mainframe. We have a third place where control got dispersed. That's in the mainframe itself. Because now we have configuration files and administration and administrative staff for VTAM, TCP/IP, the HTTP daemon, WAS, FTP, the Java virtual machine, the Java programmers, the COBOL programmers, the MQ administrators, and so on. So with the added flexibility, we've gotten additional complications, which makes it very difficult to implement management controls, because we want to be able to manage all of these different issues here, and because the controls have been dispersed, it's very difficult to do this, especially when all these different people are involved. So we've got lots of different control points to worry about, and if we want to deal with the situation, the first thing to do is to recognize it. A lot of people have discovered that things got very, very complicated and we didn't even realize it. We were concentrating on the additional flexibility we were getting and not realizing the effects this has on our management controls. So with all of these different control points to worry about, we need to recognize that with all of this, all of the different things, I don't need to read this to you. If you want to know security is good, if you want to have good, reliable systems with good functionality, if you want to manage the whole operation with good response time, reliable change control, cost controls, all the basic things that you'd want to do, you need to have the management controls in place. And if you don't realize how the control options have been dispersed, that's your first step in managing the situation. We will have security breaches, we'll have cost overruns, we'll have audit failures, we'll have service level problems, and we'll have a whole lot more if we don't find ways to implement some basic management controls. To do this, we're either going to need some magic cross-platform, cross-internet management control tool. I don't know of any tool that does this. Or the other option, which I find more appealing, is to find a way to get back to a simpler architecture. Well, now that I've laid out some of the issues and some of the ways things have gotten more complicated, I'll leave this to other people to talk about solutions. If you want some more information on any of this, here's some sources for more information, and I look forward to getting comments or feedback from you, because we all need to be addressing these issues. Thanks very much. Back to you, Yvonne.
Thank you, Stu. Boy, times sure have changed. Patrick Fournier from SysperTec will present a modern solution to securing access to your host assets. So I'll hand the presentation over to Patrick now. Patrick?
Thank you, Yvonne. My name is Patrick Fournier. I am a solution architect for the Virtel product line. As you will see, Virtel Web Access addresses heads-on the security challenges that Stu discussed because it eliminates the complexity and security exposure that result from distributed TN3270 emulation applets. It brings the control of access to mainframe assets to the mainframe where it belongs. It relies on a simple mainframe-hosted solution that uses the web browser as a 3270 terminal emulation client. So, let's start with a brief introduction to Virtel Web Access. Virtel Web Access is Virtel's base configuration. It functions as a thin client, browser-based TN3270 emulator. It serves 3270 screens as standard HTML JavaScript pages with 3270 emulation ergonomics to thin client devices straight off the mainframe without middle-tier server. It doesn't get any simpler or more centralized than that. Virtel is typically deployed as a modern alternative for TN3270 emulators such as PCOM, HOD, Extra, Roomba, and Bluezone. Virtel relies on a thin client browser-based architecture, which means that the TN3270 applet that TN3270 rely upon is replaced by the client's web browser, to which Virtel Web Access serves a standard HTML JavaScript web page. 3270 application screens, such as those of CICS, IMS, TSO, and other 3270 applications, are served by Virtel Web Access as HTML JavaScript web pages with 3270 emulation ergonomics. Those pages can be rendered by any web browser running on any web-enabled device. Consequently, Virtel Web Access works instantly with any web client available today or tomorrow, any version of Windows, any Apple product, any tablet or mobile device. The thin client architecture of Virtel Web Access makes for a simple and instant deployment because there is nothing to install on clients or middle-tier servers, and users simply point their web browsers to an installation-defined URL to reach the logon menu. And the thin client architecture of Virtel Web Access also simplifies administration and support because there is nothing to administer or support outside the mainframe, no client app, no middle-tier server, no Java component. The administration and support are 100% host-based. The first page that Virtel Web Access serves to users that successfully underwent their logon authentication is an application selection menu. On that menu, only those applications that the user is authorized to access are listed. Applications that the user is not authorized to access are not listed. Applications that are started and available are identified with a green light. Applications that are not available are identified with a red light. The application selection menu, together with the multi-tab capability of web browsers, works as a simple session manager, to the point that some Virtel customers have dropped their session manager. The same application selection menu is served again to users after an application or transaction crash, to prevent the users from roaming free inside the host as they would with TN3270 emulators. Here is what a 3270 terminal emulation page served with Virtel Web Access to a PC workstation looks like. It looks and works exactly like a green screen. The only clue that it is not a green screen is the toolbar at the top of the screen and the web browser tabs. Now, let's see step by step how Virtel Web Access works. 3270 applications such as CICS, IMS, and TSO have a screen-based interface. Screens are served to users via VTAM SNA connection. Virtel Web Access, which runs as a starter task on the mainframe, behaves as a regular VTAM terminal, but behind the VTAM relay are a protocol converter between host and web connection technologies, and an IP server which manages the HTTP connection with web users. To generate a 3270 terminal emulation web page, Virtel Web Access inserts the 3270 data coming off VTAM into predefined HTML JavaScript templates. The Virtel scenario and template shown on this diagram guide the transformation process. They are what makes Virtel Web Access behave as a 3270 terminal emulator. With different scenario and templates, Virtel could convert the screen user interface into a modern GUI or serve the host application as reusable web or message services. But that's another story for another day. In any case, the resulting web page can be rendered by any web browser running on any device. Now that you understand the basics of what Virtel Web Access does and how it works, let's review its security features. And first, let's start by reviewing the design principles that serves as a foundation to our web access security. We firmly believe that the simple centralized infrastructure of Virtel Web Access, which relies on 100% standard web technology, is easier to protect than the decentralized infrastructure and SNA over IP connections that TN3270 emulators rely upon. We rely exclusively on standard web technology for the web connection and web client, that is, end-to-end encrypted HTTP connections as opposed to TN3270 connections, and using the web browser as the client as opposed to Java client applets. We keep the control of access to host assets on the host where it belongs, whereas TN3270 emulators rely on distributed Java client applets, which results in distributed security exposures, which results in the host losing control of access to its own assets. We also believe that with web-originated accesses, user authentication has become very critical. Are you really who you say you are? Single-factor authentication such as the RACF user ID and password is no longer sufficient. Multi-factor authentication such as that provided by SSO systems is becoming a must. Nobody has the resources of IBM, Google, and Apple and other top software publishers when it comes to security investments. So we believe that the smartest thing to do is to leverage the security investment made by those top dogs whenever possible. For example, we leverage IBM ZOS statement of integrity by keeping as much of the web access solution as possible inside the host where it gets the best possible protection. We also leverage IBM's ATTLS and ICSF for the SSL encryption of HTTPS connection. By relying on web browsers instead of client applets, we leverage the huge investment that Google, Microsoft, Apple, and Mozilla are making to improve the security of their web browsers. And by positioning ourselves as an integration component between host applications, host security system, end users, and multi-factor authentication products, we leverage the innovative solutions that come from the SSO marketplace. Now, on to a more novel territory. We believe that ultra-thin translates directly into ultra-secure, that the key to a truly secure web access includes virtual device infrastructure and cloud technologies. From a security point of view, ideally, 3270 clients should be ultra-thin with only the OS, web browser, and whitelisted applications. Desktop applications should be provided as cloud services, such as, for example, Microsoft's Office Online, Google's G Suite for the cloud, and Apple's iWork on iCloud. And of course, 3270 application screens should be served as web pages to the client's web browsers, as we do with Virtel Web Access. We understand that not every organization is ready to go that far in streamlining their client workstations, but it is feasible, and I will later showcase a recent project where one of our customers replaced their TN3270 workstations with ultra-thin clients that access both desktop and 3270 applications in the cloud via the web browser. Now on to an even more novel concept. From a security point of view, we believe in strict client device management using a mobile device management product. This is the only way to ensure that your ultra-thin and ultra-secure clients remain ultra-thin and ultra-secure. So you treat all 3270 client devices, including PC workstation, as mobile devices, limit the software to OS, web browser, and whitelisted applications, automate the software and security updates, segregate corporate data, emails, and documents from personal ones. Those are the security design principles that we believe in. Throughout the rest of my presentation, I will point out when Virtel Web Access adheres to those design principles. By the way, those red boxes to the left, they are our stamps of approval. They will be used in the following slides to remind you of our key security design principles. When it comes to security, the strengths and weaknesses of a 3270 terminal emulation solution result directly from its architecture. Let's compare the architecture of Virtel Web Access to that of TN3270 emulators. TN3270 emulators rely on TN3270 connections and distributed client applets, typically Java client applets. Instead, Virtel Web Access relies on host-running middleware, end-to-end HTTPS connections, and client web browsers to which Virtel serves standard HTML JavaScript web pages. So, with Virtel Web Access, we keep the control of access to host assets on the host where it belongs. We rely exclusively on standard web technology outside the host, and the web browser is our client. We are now going to review the security features of TN3270 emulators and Virtel Web Access end-to-end, from the host to the client through the connection, starting with the internet connection. TN3270 emulators rely on TN3270 connections. TN3270 connections do support SSL encryption, but not all TN3270 applets do. And even when they do, they may not be supporting the same SSL encryption level because it requires consistent applet upgrades to support the same SSL encryption level. One of our prospects must support several SSL encryption levels because their users are on different levels of TN3270 applets. It is quite cumbersome and not very secure, actually. In fact, most TN3270 emulation users have not deployed the TN3270 encryption. They rely instead on a VPN, which of course comes at an extra cost and with extra support requirements. With Virtel Web Access, it is quite simpler because Virtel Web Access relies on end-to-end HTTPS connections. Those connections are SSL encrypted with either ATTLS or ICSF, which, being IBM products, are always compliant with the latest FIPS levels, today 140.02. Although Virtel can coexist with a VPN, it doesn't need a VPN to encrypt the data exchanged with terminal emulation users. In fact, some of our customers have simply dropped their VPN. Virtel also manages unique session and exchange identifiers. Although these identifiers are infrastructure components used by Virtel to manage the sessions and exchanges, they also work as an embedded security feature because they allow detecting and rejecting man-in-the-middle attacks. If a message comes back from a client with an incorrect session and exchange identifier, Virtel immediately ends the session. So Virtel relies exclusively on standard web technology outside the host, leverages IBM's ATTLS and ICSF encryption, and it keeps the control of access to host assets on the host where it belongs. Now let's talk about 3270 field attributes. As you know, 3270 applications assign one of the following attributes to each screen field. A hidden field shouldn't be displayed to anyone. A protected field can be displayed but not updated. An unprotected field can be displayed and updated. TN3270 emulators rely on their distributed client applets to enforce those attributes. They send hidden fields outside the host firewall all the way to the clients, and they don't check upon return to the host if protected fields have been changed. This is a security gap. It is known to hackers. It has been used to compromise host data. Virtel Web Access, which runs inside the host firewall where it is protected from web attacks, strictly enforces the 3270 field attributes. Virtel does not send hidden fields outside the host, and it checks if protected fields have been changed upon return to the host. If so, Virtel immediately ends the session. With Virtel, the control of access to host assets is kept firmly on the host where it belongs. Now, on to custom-defined data filtering. Same concept as the 3270 field attributes we just discussed, but with custom-defined data filtering. Client-based TN3270 emulators simply do not offer any custom data filtering capabilities. Through custom-defined scenarios and templates, Virtel Web Access enables administrators and security auditors to filter outgoing and incoming data flows. For example, outgoing data field can be hidden, masked, or encrypted. Incoming data fields can be protected from updates. This data filtering can be based on user credentials and authorization levels. It takes place on the host beyond the protection of the host firewall. Once again, the control of access to host assets is kept on the host where it belongs. Now on to the mainframe authorization system, RACF, ACF2, or top secret. With TN3270 emulators, users are authenticated once at logon and their authorization is not memorized. When an application crashes, users are sent back to the USS tab where they are free to access unauthorized applications if they know how to do so. When a transaction crashes, users are free to access unauthorized transactions. Instead, Virtel Web Access memorized the logon authentication and authorization in the form of an application selection menu that we displayed a few slides ago. When an application crashes, users are sent back to their own application selection menu, and administrator can define a fallback procedure that Virtel will implement when a transaction crashes, for example, sending the user to the application selection menu. The bottom line is that Virtel users are never allowed to roam free inside the host after an application or transaction crash. Another instance, actually, of Virtel Web Access keeping the control of access to host assets on the host where it belongs. Here is the application selection menu that Virtel Web Access serves to a user after a successful logon. It reflects the user's authorization level as identified at logon by RACF, ACF2, or top secret. The same exact menu is served again to the user after an application or transaction crash. It prevents the user from roaming free after an application or transaction crash. Now let's discuss web access audit trail. Client-based emulators simply do not provide any web access audit trail. But Virtel Web Access enables administrators to define the web access audit trail that they want to save. For example, no tracking when retrieving an image, but tracking when using a VTEM relay. This data can be used to feed a non-repudiation process, and it can be stored in a vSAM file or in SMF. By default, this would be the SMF record 223. Once again, Virtel Web Access keeps the control of access to host assets on the host where it belongs. Now on to the main difference between Virtel Web Access and TN3270 emulators when it comes to security. which is the Java client applets or lack of thereof. TN3270 emulators rely on distributed client applets, typically Java client applets. When it comes to security issues, Java is the second most notorious software right after Flash. Java updates are periodically published to patch the Java security exposures. Distributed Java client applets are quite sensitive to those updates, and it makes the support of distributed Java client applets particularly cumbersome and costly. Of course, if the Java security updates are not applied, the TN3270 clients may be exposed to attacks. With TN3270 emulators, the host security relies on the safe practices and regular Java software updates of hundreds or thousands of distributed TN3270 emulation users who know who they are and where they are and whether they are applying those Java updates. All it takes is one compromised TN3270 client to expose the host assets. The host can verify that all TN3270 clients are safe and that none is compromised, and in effect, the host has lost control of the access to its own assets. With Virtel Web Access, the web browser is the client. For each new 3270 screen, Virtel generates and serves a new and uncompromised web page, which is rendered inside the web browser sandbox. The web browser sandbox is a much safer environment than any Java client applet. And web browsers are getting safer all the time, thanks to the huge security investments of their publishers, Google, Microsoft, Apple, and Mozilla, for whom security is a growing requirement and a growing differentiator in their competition for market dominance. With Virtel, the security of host assets doesn't rely on hundreds or thousands of distributed clients. The host remains full control of access to its assets. The web client, the web browser is the client, and Virtel leverages the security investment made by web browser publishers. Ask yourself, what technology do you want to rely on to secure the access to your host assets? On one end, you have TN3270 emulators, which rely on notoriously unsecure Java technology, and for some of them on the Java plugin that has now been deprecated by Oracle. On the other hand, you have web browsers whose publishers are industry giants that have clearly demonstrated in recent years that security was a top priority by discontinuing the plugins responsible for security exposures and by sometimes engaging into considerable re-engineering or redevelopment efforts, such as, for example, Microsoft, who redeveloped Edge, a brand new web browser from scratch to replace its existing web browser, Internet Explorer, mostly to improve the web browser security. Talk about a costly investment into security. It is obvious to us that relying on the web browser rather than Java components to secure the access to your assets is the better choice. Now on to macros. Macros are user-developed productivity improvement tools that work as basically application extensions. Because of their business value, they should be treated as a business asset. And left in the hand of end users, they can create serious security exposures to host assets. So with TN3270 emulators, users develop, manage, and store on their workstation any macro they want. There is typically no inventory of those TN3270 macros, and they do not undergo any security or administration audit. There always is a great deal of redundancy between user-developed macros and little or no sharing. Some of those macros create very serious security exposures. For example, we've seen logon macros that contain unencrypted RACF user ID and passwords, and we have also seen macros that feed from an Excel spreadsheet to activate thousands of transactions at once. Such macros are very dangerous to the host assets. All it takes is one compromised client device to wreak havoc on the host assets. With those distributed macros, the host has lost control of the access to its own assets. And additionally, despite being a business asset, those macros are owned and managed by the developers, the TN3270 emulation users, and the business has no control or ownership of them. Virtel Web Access enables organizations to replicate what they were doing with TN3270 macros if that's what they want to do. But Virtel Web Access also enables the administrator to force all user-defined macros to be stored on the host, safe and secure behind the host firewall, where they can be inventoried, audited for security issues, and shared or not between users. Administrator can eliminate the duplication and organize the sharing. IT programmers can participate in the development of general purpose macros, and auditors can ensure that the macros do not cause unwanted security exposures. This productivity tool, application extension, and business asset is back under the control and ownership of the business and its IT department. This is another instance where Virtel Web Access allows keeping the control of access to host assets on the host where it belongs. What about discontinued clients? With TN3270 emulators, the Java applets and macros are still exposed while the TN3270 clients are disconnected from the host if they are still connecting to the internet. Instead, Virtel Web Access doesn't leave any component exposed to attack while the clients are disconnected from the host. This is another security benefit of using the web browser as a client. To complete the end-to-end securing of the web access path, it might be a good idea to protect the 3270 clients from attacks by treating them all mobile devices and traditional PC workstation as mobile devices and managing them with a mobile device management system to restrict the software configuration to operating system, web browser, and whitelisted application. Apply automated software and security updates when the devices connect to the internet. Segregate corporate data, emails, and documents from personal ones. This is quite a departure from today's software-heavy 3270 client workstation, and it may not be for every organization, but it can be done, and it generates tremendous benefit as experienced by our customer Frequent. So let's review the shockingly novel project of our customer Frequent. What Frequent did fits perfectly within the scope of this presentation because it embodies the key principles that have been used to design Virtel, its architecture, and its security features. Depending what side of the fence you are and how long you have been in the mainframe industry, you could say that Frequent has redefined the future of the 3270 client workstation, or that they have reinvented the dumb terminal in the age of the internet. You decide. With 58,000 vehicles in 15 countries, Frequent manages the largest European commercial vehicle fleet. In 2016, Frequent decided to get out of the mainframe client workstation business altogether by replacing the 1500 Windows PC workstation used to access their mainframe applications with minimalist Chrome-based devices from which all applications are accessed in the cloud. This is what Frequent's new 3270 client workstation looked like. The traveling staff got Chromebooks, the office staff got Chrome-bit dongles that they connected to their monitor, keyboard, and mouse. Chrome-bit dongles, by the way, are about the size of a candy bar and they retail for just $85 in the US. Quite a bargain. Either devices connect to the internet via Wi-Fi. Only Chrome OS, web browser, and whitelisted application can be installed on those devices. For desktop application, Frequent went with G Suite for the cloud, which is Google's version of Microsoft Office Suite, except it is provided as a cloud service. For 3270 applications, Frequent went with Virtel Web Access. Frequent manages all those Chrome devices with the Chrome Device Manager. They ensure that only authorized software is installed on the devices. They push automated software and security updates to the device. They segregate corporate data, email, and document from personal ones. Also, this enterprise-wide virtual device infrastructure initiative was initially aimed at reducing cost, and it did drastically. It resulted in the design of an ultra-thin and ultra-secure client workstation, one with greatly reduced and simplified support requirements, and with unparalleled mobility and flexibility. As said earlier, you can look at it as a mainframe client workstation of the future or a return to the dumb client workstation of the 70s. This project embodies four of our dear security design principles. The web browser is the client. The control of access to host assets is kept on the host where it belongs. Only standard web technology is used outside the host. It leverages the security investments made by IBM and Google. Once the path from client device to host application has been secured, the last security requirement is user authentication. Are users really who they say they are? User authentication has become more complicated and more critical with web access. Single-factor authentication based on RACF user ID and password is no longer sufficient. Multi-factor authentication is highly recommended. It typically includes a combination of something you know, something you have, and something you are. Something you know, for example, your mainframe logon or an alternative logon or a response to a secret question. Something you have, for example, a smart card, USB fib, PIV card, client certificate, or a safe pass code sent to your own personal mobile phone or email. Something you are, for example, your device name, IP address, or biometrics. Multi-factor authentication typically combines modern authentication technologies such as those listed below. I'm sure that you recognize them, and I will spare you the alphabet soup. So, what is the role of Virtel Web Access with multi-factor authentication? Virtel can coexist and integrate with any IP technology, including SSO and proxy server, and custom-developed Virtel scenarios integrate the SSO, host application, RACF, and end user, as illustrated in the next slide. The diagram here illustrates how Virtel integrates SSO, RACF, host application, and end user into a comprehensive, seamless, multi-factor user authentication and web access system. First, the end user requests access to some data or screen via a multi-factor authentication system. Virtel is of course not involved in the multi-factor authentication itself, but it receives from a server authenticated by its IP address and server certificates a web request from a user that has already been authenticated by the multi-factor authentication system. Virtel then requests a pass ticket from RACF for a one-time access to the requested host resource. Virtel uses a pass ticket to get the requested screen or data from the host application. And finally, Virtel sends the requested screen and or data directly back to the end user. This is pretty much how most of such integration work. One of the strengths of a system like that is that it doesn't move around any user ID or password, encrypted or not. On this final slide, I have listed all the components of our end-to-end web access security, the different subjects that we covered during this presentation. Note that Virtel is solely responsible or a key participant for all but one of the security features. At this point, this concludes my presentation of Virtel Web Access and its security features. Thank you for listening to it. I hope that you now understand how a centralized thin client and browser-based web access architecture like that of Virtel is key to securing the access to your host assets. I will now hand over to Yvonne and John Bachiochi for QA session.
Thank you, Patrick. We have John on the line now, John Bachiochi from SysperTec. He's here with us to help with the Q&A. We're only going to have time for a few questions, so let's go ahead and get started. And hi, John, and welcome. And my first question we have is, how complex is it to implement those security features with Virtel? And a follow-up, how much time does it take?
Thank you, Yvonne. The installation of Virtel includes a 15-minute pre-installation orientation call where a checklist describing the tasks to perform and resources that are required is reviewed. Then there's the installation itself, which is done by the customer and typically takes less than 2 hours. After that, there's a tailoring of the product, which includes definition of lines and applications to Virtel and performance tuning, which is typically accomplished with the step-by-step guidance of Virtel technical support via a WebEx, and that usually takes about an hour. Then you have testing of the product for a period of time, normally a few weeks, without the final security setup. And then finally, discussion and planning of the security setup with the help of our product support team, who will then assist you with the step-by-step tailoring of Virtel to support the agreed-upon setup. Would like to emphasize that the Virtel product support team takes an active hands-on role in supporting the installation, tailoring, and security setup of Virtel Web Access.
Okay, that sounds great, very detailed. Second question, will Virtel work with hardware encryption as opposed to ATTLS?
The answer to that is yes, it will. It can interface with products, for example, like IBM's ICSF to encrypt data fields.
Okay, great. Third question, what is the best way to configure Virtel to support single sign-on authentication?
Security context information can be extracted from the authentication servers such as like an LDAP server and passed to Virtel as a header. This will always be the user ID associated with the person being authenticated, and once Virtel has that information, which is normally passed as an HTTP header, Virtel requests a pass ticket to support logging on to legacy applications.
It looks like that's all we have time for today. I want to thank Stu Henderson, Patrick Fournier, and John Bachiochi for joining us today. Also, thank you to Cher for hosting our webcast, and we'd like to thank you all for joining us today. I hope you found something new and thought-provoking to take away from the webcast. Remember, if you have any questions or you'd like to talk with someone at SDS about Virtel Web Access and how it can help in securing access to your host assets, you can reach us via email at info@sdsusa.com or call us at 1-800-443-6183. If we didn't get to your question today and you've opted in so we can contact you, we will get back to you with an answer to your question after the webinar. Once again, thank you for joining us today. This concludes our presentation.